Hello, hello, and welcome to the dry run of the course Digital Circuits. This will be taught by Professor Shantanu Chattopadhyay. This will be taught by Professor Shantanu Chattopadhyay, and I am Utresh Padwaje, and I will be assisting him in this course. So this live session recording is a part of dry run in which I will be testing out the equipment that I will be using to host these kind of sessions in which I will try to solve some problems and clear out doubts of the students. So starting with the course outline, so this is well known to the students who are taking the course, but again I will briefly go through it. So we'll start with the basics of digital electronics, in which we'll get to know about the number systems, the algebra regarding that, how to realize the functions. So this will be done on pen and paper, and then how these are transformed to logic gates, and how these gates are then used to perform different arithmetic calculations, and how they are converted to storage and eventually into computers that we know. So for that we will learn about microprocessor 8085, and the concepts that we see in this part will be again applicable to the new computers and the ones that we are currently using. So using this simpler architecture, we'll get to know how the computers are functioning. So as a part of this dry run, I have prepared some questions and I will be trying to solve them in this live session, and I will see whether my equipment works properly or not. So I'll switch to pen now. So yeah. So the first question is, which number system has a base 16? So before starting this course, this can be a bit confusing, but straight away I can tell you that the answer is hexadecimal, because this word itself means 16, octal means 8, binary means 2, decimal means 10. But what does this base 16 means? So as we will go through the course, we'll get to see that numbers are written like this fashion. So your number might be written inside this bracket, which is denoted by this B. So this B is the base. So what does this base suggest? So base suggests the number of numbers or distinct characters that you have to denote your information. Like if you have a base 2, so base 2 numbers will just use 0 and 1 to denote any quantity. Similarly, octal would be using 0, 1, 2, 3, 4, 5, 6, and 7. So these 8 characters will be used to denote any information. So the most commonly that we use in our lives is decimal. So these are the numbers 0, 1, 2 through 9. So these 10 characters we use to denote any information. Similarly, these other two bases also exist, so these have their relevance while we learn more about computers. Coming to question number 2, so this is an interesting one. So, how this hexadecimal number can be denoted in this octal system? So, before starting to solve this question, let me just write down the methodology which will give us get to the answer fastest. So this number that we have in base 16, we will convert it to a base 2 number, and from this base 2 number we will go to this octal base system. So what we have here is 1e.43, that will convert to some binary number, and then again that will be converted to octal. So how does hexadecimal to binary conversion works? So every number would be denoted in groups of 4 numbers in binary system. So in that case, This 1 will become 0001 in binary because we only have 0 and 1 in binary to denote these numbers. E will become 1110. We have a decimal here, so decimal will follow after this. 4 becomes 0100 and 3 becomes 0011. So if you write this down in binary, this will be 0001 1110, your decimal point, 0100 and 0011. Now half the part is done. Now we need to get this binary number to a requisite octal number. To convert this to octal number, we need to group this quantity in groups of 3, starting with this decimal point. So from the decimal, if we are going towards left, we'll start the grouping in this fashion. So this last group, you can see it is not complete, so we'll just add 10. So this group is now complete. Similarly, to the right side of this decimal, we will start grouping in this fashion. And again, here the last group is not complete, so we'll just add 10. So if we write down these groups in the same order in which they were written, they will be something like this. And our decimal point lies after 110. So if we write this down in octal number systems, 000 denotes 0, 011 denotes 3, 110 denotes 6, decimal point is there, 010 denotes 2, 000 denotes 0, and 110 again denotes 6. So if we write this down in its octal form, this will be 36.206 with base 8. So if we see, B will be its correct answer. Now coming to the next question, here we need to perform the binary addition of these two numbers. So let's write down these numbers first. 101, 001. We will denote the operation 010011. Perform any kind of addition, you need to know what is the addition of these two numbers. So in case of our binary system, we only have 0 and 1. So the combination of additions possible that we can write down for our reference, so we can readily see that. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1, 0. So here we will write down the 0, and this 1 will go to carry, and it will affect the next addition. So let's start adding up the numbers that we already have here and that we have written down. So the first one is 1 plus 1, that corresponds to this case, that will give out 0. Let's write down the carry at top. So this 1 goes to carry. So we have a 1 in carry. The next addition that we need to perform is again 1 plus 1. So this again corresponds to this fourth case. So we will write down the 0 and 1 will be written in carry. Now this is 1 plus 0. This is our third case. So this gives out 1. So we'll write down the 1. There is no carry now. So next case is 1 plus 0. This is again this third case. This will give out 1. So we'll write down 1. After this, we encounter 0 plus 1. So this is our second case. This also gives out 1. And our final addition is 1 plus 0, which is our third case, that gives out 1. And again, no carry is left. So this completes the addition. And this is our base 2. So this is 1, 1, 1, 1, 0, 0. So here the option B corresponds to the correct answer. Now coming to this question, what kind of quantity is temperature? So here there are two type of quantities mentioned in the option. One is analog, one is digital. So let's denote a sin x function. So sin x looks like this. So here if you notice carefully, for every x you have a unique value of sine. So if you go in between this period, and do not consider the further part. So every x will be having a unique value of sine x. Rather than saying unique, we can say there is a continuum of values that lies between plus 1 to minus 1. And if you try to define this with some numbers, let's have some decimal point is there, and if you have a large numbers that you can use to denote every point, you can denote every point with very high precision if you have a very large number of decimal of values after decimal point. So this is what analog quantity looks like. So if you have the characters to represent, you can represent it very precisely. And let's see what digital quantities look like. So let's say we have this square wave which is having values minus 1 and plus 1. So between a region, this can be having a value of 1 or minus 1 only, nothing in between them. So this is an example of digital quantity which is having a discrete value at every point, either it's 1 or minus 1, unlike sin x. So sin x can be something very precise that can be shown if you have enough number of characters to show that number after a decimal point. So now let's get back to our question. So temperature, most commonly everyone would have encountered to the temperatures which are denoted using decimals. So like 23.6 degrees Celsius, or if you even go to some digital thermometers, there you can see 3 places after decimal. So as you are able to adjust the temperature with higher precision, with that you can denote this quantity even in a better way. So temperature is an analog quantity and not a digital quantity. So answer to this question is A, analog quantity. Now I would like to thank you to go through this dry run and bear with me so that I could test out my equipment and also whether the problem solving is comfortable with this setup or not. So feel free to write down on the problems or any discussions regarding to this course to my email ID utprekshpmrfta@gmail.com, and I will be happy to reply. Thank you.